Saeed. I will be your instructor for the for this small session on the routing protocols. As you can see, I'm injured, so actually I am not going to be able to write something while we actually record this. So I have got everything prepared here on the board. So before we actually start explaining everything about the routing protocols, let's just try to remember from the previous session what a network is, because understanding this will help us to better understand the idea of the routing protocols, right? So from the previous session, we can remember that a network is actually a group of devices or interconnected devices for the purpose of sharing information and resources, right? So in order to be able to share the information and resources, this means that the data or the traffic has to travel from one place to another in order to reach the destination. So reaching the destination means that whether this traffic or data already knows about the path to reach that destination, or actually it's going to be told, right? So if you understand this, this actually is going to make it easier for us to understand the entire routing process, right? So before going to explain, before explaining actually the different types of routing that we have, right? Let's just identify or have like some simple definitions. So the routing process actually, or the routing, in order to understand the routing process, we have to understand two definitions here. The first one is actually the routing, right? The routing is actually the process of selecting the best path, right? So selecting the process of selecting the best path for the data or traffic in order to reach the destination, right? Because if you can imagine with me, the network, there might be like actually several ways or several paths for the same destination, right? So selecting the best path is actually called the routing. And if we recall from the previous session, when we were explaining the different types of devices that we use in the network, we mentioned that one of the most important devices in our network is called a router, right? So the router, if you remember, is actually the device that actually performs the routing process, right? So right now we have the routing explained. Let's move to the other definition. The other definition actually is the protocol, right? Because we are going to meet this word a lot. So a protocol is a set of rules that governs a certain process. So we have a process here. The process actually is the routing, right? So we're going to select the best path for the data or the traffic in order to reach the destination, right? So we have to control this process. We have to have some regulations, right? So who is going to control this is the protocol, right? So right now, if we understand everything that I have just mentioned, right now we can move on to the next step, which actually understanding the different types of routing that we have, right? Or how we can perform the routing. As we mentioned, just keep in mind that the routing is the process of selecting the best path for the data to reach the destination. So whether I tell the router, right, about the path, right, to reach a certain network, right, this means that since I'm going to tell the router by myself, so actually this means I'm going to do this manually, right? So actually this is called the static, as we can see here. This is called the static, and obviously the other type would be the opposite of the static, which would be automatic or dynamic. So right now we have two main types of routing. The first one is the static routing, and the other one is the dynamic routing, right? So in the static routing, we don't actually need protocols, right? Because actually it's something that we do manually, right? So we are going to control this. However, in the dynamic routing, we need protocols because actually this process is going to be dynamic or automatic. So we have to have some rule that actually is going to control or govern this process, right? So before moving to the dynamic routing protocols, again, the static routing means that I'm going to enter a command in the router in order to tell the router how to reach a certain destination, right? We are going to show, of course, in the next sessions what the syntax of the order itself. So don't worry about this at all. Right now, let's move to the dynamic routing protocols. Dynamic routing protocols are divided into two major groups, right? The first one is called the interior gateway routing protocols, and the exterior gateway routing protocols. So what actually I like about the networks is that most of the definitions or most of the topics that we have, they are self-explanatory. So if you, for example, imagine, or if you understand what these words mean, so actually you understand what the entire definition or what actually this topic is talking about. So we have here the interior gateway routing protocols. It means that we have some protocols that we are using them interiorly, right? We're not using them exteriorly. And the exterior gateway routing protocols is actually the opposite, which means that we are using them exteriorly. So first of all, like we have to know, for example, what actually we are using these protocols in and what we are using these protocols out of, right? So the interior gateway routing protocols, right, are protocols that are used in the same autonomous system, right? So if you don't know what autonomous system is, it's very simple, right? We use the AS, right, to refer to autonomous system. Autonomous system is the network actually under the same or single administrative control. So for example, as long as I am controlling the network, whether it's a small network or large network, as long as it is under my control, so I'm using one of the interior gateway routing protocol, when actually the network needs more or has more than administrative control, actually means that right now we are moving to the bigger picture. We are using the concept of the autonomous system. So inside the autonomous system, the same autonomous system, for example, let's imagine a large network. For example, a network like Microsoft, for example. They have their own network, so this actually is considered an autonomous system, right? We are using this. We use the interior gateway routing protocol under or in these networks, while we use the exterior gateway routing protocols between the different autonomous systems. So if we have different autonomous systems for different networks, for different organizations, different entities, and we would like to route information between these autonomous systems, then we will not be able to use one of the interior gateway routing protocol. We will use the exterior gateway routing protocols, right? So the interior gateway routing protocols are also divided into two main groups or teams. For example, let's say groups. The first one is called the distance vector routing protocols and the link state routing protocols, right? So in order to understand the difference between these two types, let's just explain what distance vector are and what link state are. So the distance vector routing protocols, they are dynamic routing protocols that uses the distance as the metric and the distance and the direction as the metric. So, for example, let's just go further and speak about one of the distance vector routing protocols, which is called DRIP version 1. This actually stands for Routing Information Protocol, right? It's a distance vector routing protocol, which means that it uses the distance as its metric, right? The metric is actually a value, right, that actually determines what path is going to be selected and installed in the routing table. If we recall, when we were discussing the routers, we mentioned that since the routers are actually responsible for performing the routing process, so they have to have information about the best paths to other destinations. So the information about the best paths to other destinations are actually installed in something called routing table. All of the routers, they have routing tables, right? It has the best path for each destination in that routing table. So the metric is actually a value that the routing protocol uses and that actually to decide which path is going to select to reach that destination. So for example, we said here that the metric of the RIP version 1 is called the hop count. Hop count means that we are going to, not us, the router which has RIP version 1 running will calculate or count how many hops or routers are in the way from the source to the destination network, right? And it's going to compare between the path that it has, and it's going to install the path with the lowest number of hops in the routing table, and in the same time it's going to tell how to reach that destination or what interface it has to go to in order to reach that destination, which is the vector, right? The other type of the distance vector routing protocols, right, is the IGRP. It stands for Interior Gateway Routing Protocol, and its enhanced version, which is EIGRP, Enhanced Interior Gateway Routing Protocol. Both of them are actually, they are not different, they are the same, but one of them was actually the enhanced version of the other. Both of them, they are Cisco proprietary, which means that they were written by Cisco. However, not anymore, because right now, since Cisco is actually doing, or like Cisco is dominating the data center world, so actually right now these are considered as open source. However, right now we are discussing how they are, or what is the relation between them, like how they are, why they are considered distance vector routing protocols. The IGRP is considered purely a distance vector routing protocol because it uses the same attributes or the same features as the RIP, while the AIGRP is somehow like a hybrid one. It does not actually do everything as a distance vector routing protocol. Distance vector routing protocol, I forgot to mention that they send periodic updates, which means they send information about the entire routing table periodically. This actually like consumes a lot of time and processing. This can actually like negatively affect the performance of the network. While the IGRP does both, it sends periodic updates and at the same time it sends triggered updates, right? So this is like a brief about the distance vector routing protocol. Right now we will move to the link state routing protocols. We have two routing protocols here, the OSPF, which stands for Open Shortest Path First. It's an open source, by the way, and the ISIS, which stands for Interconnected System to Interconnected System. These types of routing protocols are very good to for large networks because they actually scale very good. They use they send information about the link that actually was affected by the change, not the entire routing table. So actually this means they have better convergence, better performance. That's why they scale more. They scale better actually in large networks, better than the distance vector routing protocols. This actually is a brief about the OSPF. There are a lot of features for the OSPF about the process. The OSPF, there is something called the election, the areas. All of this we're going to discuss further separately when we come to each routing protocol separately. Finally, we have the path vector routing protocol. The only path vector routing protocol is the BGP. Stands for the Border Gateway Routing Protocol. Most of the people, or previously, it was considered as a distance vector routing protocol because it's not a link state routing protocol, and it cannot perform or act as a link state routing protocol because this is the dominating protocol of the internet. And of course, we can imagine a network of the size of the internet with all of these changes. If it's actually using a link state routing protocol, it will never work because the number of the changes and the updates will be like tremendous, and the routing cable will be congested, and it will be very actually difficult to use a link state routing protocol inside the internet. So we use the BGP. It is not actually or purely distance vector routing protocol. It uses the path, right, in order to select the best way to reach the destination over the network. That's why it's considered as a path vector routing protocol. The metric of the BGP is actually something. It's not actually one value or something. They are something called attributes. We're going to discuss this also when we come to the BGP. So finally, at the end of this session, let's just have a small recap about everything. We spoke about the network. We spoke about the routers in order to understand the routing process. We spoke about the routing process. We spoke about the protocol. We understood the two types of the routing that we have. We understood also the different types of dynamic routing protocols that we have, and the We said that we have interior gateway and exterior gateway routing protocols, and we also mentioned that the interior gateway routing protocols are divided to the distance vector and the link state. We spoke about the REP version 1 and the IGRP in the distance vector routing protocol, OSPF and the link state routing protocol, and finally we mentioned the only exterior gateway routing protocol which is considered a path vector protocol, which is the BGP. All right. So that actually was the end of our session. I hope this was informative, and thank you so much for viewing.